Now let us see how to find the higher order derivative of a parametric function. Now this has a slightly different procedure and we have to understand it properly. We know that if x is some function of t, say f of t, and y is some another function of t, say g of t, then derivative of y with respect to x is given by dy by dt upon dx by dt. So we are already familiar with this differentiation of a parametric function. But you know that just gives us the first derivative. So the question is how to find the second order derivative of y with respect to x, where y is a parametric function of x. So what do we do is, second derivative, that is second order derivative, is nothing but the derivative of first order derivative. So that is nothing but d by dx of dy by dx. Now what do we do is we use here the chain rule, that is first we differentiate this particular quantity with respect to the parameter t, right? And therefore we have to multiply by the derivative of t with respect to x using the chain rule, isn't it? So therefore that further equals to derivative of dy by dx with respect to t. So this term remains as it is. But if you consider the next term, that is dt by dx, that can be taken down to the denominator as dx by dt, right? Because that is the rule of inverse function. So therefore this particular last expression gives us the value of second order derivative of y with respect to x square. And of course whenever we have any denominator, that should be equal to non-zero. So using this particular process we can find out the derivative of the parametric function, which is basically the second order derivative of parametric function. Now let us solve one example related to this. Find d square y by dx square if x is a cos t and y is b sin t. Now as a first step we have to find out the first order derivative, and for that we must first find out the individual derivatives, that is dx by dt is equal to, now x is a cos t, so derivative of cos t is minus sin t, which is nothing but minus a sin t, right? Similarly let's find out dy by dt. As y is b sin t, the derivative will be b into cos t, isn't it? Now to find the first order derivative of y with respect to x, we have that as dy by dt upon dx by dt. So that turns out to be dy by dt is b cos t divided by dx by dt is minus a sin t, right? Now we want to find the second order derivative, that is d square y upon dx square is nothing but basically d by dx of dy by dx, right? Now as we know, what we have to do is we have to change the variable, that is we use d by dt of dy by dx and multiply by dt by dx. Okay. And here dy by dx is to be written in bracket. So therefore that turns out to d by dt of, now dy by dx we have already found out, that is equal to b cos t divided by minus a sin t. Whole divided by this dt by dx we take to the denominator, which becomes dx by dt, and dx by dt we have already found out, that is equal to minus a sin t. So that turns out to be minus a sin t in the denominator. Right? Now let us differentiate that. Now in the numerator you have to find the derivative of b cos t upon minus a sin t. So that is nothing but, let us take b upon minus a outside because that is a constant, so that is minus b upon sin a, and cos t upon sin t is nothing but cot t. So therefore a derivative of cot t, as we know, that is equal to minus cosec square t. So therefore I write here as minus cosec square t. Okay, and that is divided by minus a sin t, which is already present in the denominator. So therefore if we finally write the signs, that turns out to, there are 3 negative signs, so therefore ultimately the answer will also be negative. So that gives us minus, here you have b upon a into a gives us a square, and if we look at the remaining part, that is cosec square t in the numerator and sin t in the denominator, so the sin t can be considered as cosec t in the numerator, so which finally gives us cosec cube in the numerator, isn't it? Because there is already one cosec square term present in the numerator. So that is cosec cube. Cosec cube of t. This is the final answer. Alright, so that is how we use the method to find out the second order derivative of parametric function.